So this video is talking you through how to do a Criterion B part 4, which is the method. So let's go back to the grid. So method and materials, you can see that it builds up again. Limited method, then you have to do a safe method that selects materials and equipment. So realistically, that should be your basic minimum, and we need to have a risk assessment to meet that safe criteria. And then the further up you are, just basically is like a better method. So this was just a safe method. This one is now a complete method, and this one is a logical method. So it's all about how good your steps are, how easy they are to follow. The thing I will say, going back to the first ones, is you do want to look at something called command terms. I just Googled here MYP Science command terms, and the first thing I got was a PDF, and here you have all of the command terms. So when they say something like list, you can see what list is, or explain, you can see what explain means, to give a detailed account. So have that available to you. So going back to here then, our method needs to start with our equipment, I think is logical, isn't it? This can basically be a list. For this experiment where we're changing the mass of a car and rolling it down a ramp, we're going to need a car, or a trolley as they're sometimes known. We're going to need some 100 gram masses times 5 plus hanger, and we're going to need a ramp. We're going to need a stop clock or a timer. We're going to need a meter ruler, etc., etc. You need some way of propping the ramp up. You need some way of measuring the height of the ramp or the angle of the ramp. So that would be your equipment. Think about everything you would need. So putting the ramp up, you're going to need a stand for it. What stand are you going to use? What's going to be your creative way of doing it? Are you going to measure the angle, or are you going to measure the height? Which one are you going to do? And which one you do, what equipment do you need to achieve that? Then we're going to do the method itself, so the procedure. Now, there's two schools of thought here that you can do a step-by-step recipe type approach, or better is to write a description of what it does. For like proper, I remember at university it always had to be third person, past tense. So you would write something like, the ramp was set to 30 degrees, yeah? Rather than I set up, or set up the ramp. Yeah? But for MYP Science, don't worry too much. Maybe in grade 10 or the final year of MYP, you should start thinking about it and trying your best to do it properly. Certainly in the diploma program or A-levels, I try to encourage proper setup. But you need to think carefully about every step that you need to do. I don't think gather equipment is a good first step. It's pretty obvious you're going to need gather equipment. You don't need to say things like turn on laptop. I don't want to hear steps like that. What I want to hear is steps like place the ramp on a chair, adjust to be 50 centimeters, 0.50 meters above ground for the rolling surface of ramp at the very top. At the very top. So very, very specific, yeah? Going back to our things, here we have a method, here we have a complete method, and here we have a logical method. So this first bit, place the ramp, that's probably a method. This makes it a complete method. And then this makes it a logical. So here we have method, complete method, logical method. One that, as someone told me one time, can this be repeated by anyone in the world and get exactly the same results? So if you're specific enough, if you talk about the mass and the length of the ramp and the height of the ramp, anyone in the world could repeat your experiment and say, yeah, when the car was 500 grams, the time was 30 seconds. They don't get 29 or 31, they get 30 like you did. So the method is so precise that they can get it exactly the same. So that's what your method needs to be, as detailed as possible. Sometimes it's easier to write this up again after the method, which after you completed it, which is why it's sometimes written in third person past tense. The last part of it is for safety, so we need some kind of risk assessment. Probably best laid out in a table. You just identify the risk, you identify the effect of that risk, and then you identify the precautions that you're going to take to reduce or eliminate the risk. Some people might then ask you to give it a rating. I don't tend to. So they get you to rate it like a high, medium, low risk. So things like in this example where we're putting masses on, we can say masses falling, right? The effect could be land on person and injure. Precautions. One thing you can do is you can tape off an area under the masses for not stepping. Yeah? You might have the ramp might have sharp edges / metal on it. Cut or abrasion on skin. Precautions, check the ramp before carrying. And then there's always a standard one of like slips and falls. People can injured on equipment. And then so we ask for like slow walking at all times. And then things like proper shoes. Yeah? Something like that. That's your method then. So that's the full criteria B then. Yeah. Remember that in your method, I just noticed, in your method you want to be talking about so the final stages of the method. You want to make sure you talk about how many repeats you'll do, how you will measure the dependent variable, and you want to talk about then processing data. So we've got this experiment where we roll a car down a ramp, right? And then the car comes off and we time it to travel 1 meter using a stop clock, yeah? So our results will look something like this. Mass, 100, 200, whatever it was. Time, 1, 2, 3, 4, 5. 3 is the minimum number of repeats, 5 is better. Ideally, we want 5 different sets of values. Don't forget units. Then that's our raw data. So the next thing I want you to be doing is the process data. So how will we process it? Well, we're probably gonna have mass, then we're going to have average time, and then we're going to have final velocity. So you would describe somewhere here that the 5 repeats of each mass will be averaged for average time. Then the distance of 1 meter will be divided by time to give, or average time to give final velocity. My sentence doesn't make much sense, but you can write it properly. Yeah? So there won't be any results in these things. And then what you're going to do with it, you're going to create a graph of mass against final velocity. Yeah? So that's how your method should be. Yeah? Full and detailed, showing you all the stages to it. Yeah, just do the safety as the very last thing. Sorry, I thought of something after I'd finished the method. So make sure you've done all of that. I'll just scroll down it slowly so you can see it. So there was equipment, there was procedure with some do's and don'ts, how to get full marks. There's your safety. Here's what to make sure you've got in your method. Make sure you've got repeats, make sure you've got how you'll measure it, and make sure you explain how you'll process the data. And here is how you show what your processing would be. Talk about your raw data you'll gather, your process data, and your graph. And you can even set up the blank results tables and blank graph for understanding purposes.